Students, good evening. Turn on your cameras. Yes, students. Students, it is compulsory that you have to keep your videos on throughout the session. Anish as well as Ashay. Anish, Anvita, Chirag. Anvita, can you hear me? Chirag, Pratyusha, Shashank Kemman, Shashank Pujari. Students, keep your videos on throughout the session. Students, till where we have studied, I think. Okay, Anvita, but you can keep your videos on, right? Anvita, you can send a message. Okay, Anvita. Yeah. Amit, turn on your camera. Here, Chiraga. Students, kindly keep your videos on. Ashay. So, extra invitation will not be given to you, students. This is a general instruction. Chirag, are you there? Are you able to hear me? Okay, Ashay, but Chirag. Students, one small announcement is there. From next week onwards, okay, on every Tuesday as well as Saturday, okay, Tuesday as well as Saturday, you have to attempt a quiz, chemistry quiz, okay, chemistry quiz that is from 6:45 to 7:15, half an hour. Is it clear? Why am I? Oh, yeah. Okay. See, from next week onwards, every Tuesday as well as Thursday, Saturday, you have to attempt a quiz, chemistry quiz, that is from 6:45 to 7:15 in Ignis. Okay. Yeah. And if you face any problem, you have to send a mail. Okay. Should not call, send mail. So now we'll start this. 1 minute, Anvita. I'm checking actually. Medanash as well as Chirag, keep your videos on. Medanash, where are you? Anvita, I can't see. Yeah, I can see. Okay, okay. Now where are you? Yeah, I can see. Yes. Students, I think we were discussing about atomic radius. It's a variation along the period as well as down the group. That is a periodic table, and penetrating capacity. Okay, so we are discussing about a screening effect, right? Screening effect. Yes, students. Now, if electron is sorry, nucleus is there here, then this is the first orbital. This is second. This is third, fourth, fifth, sixth, etc. This is the last shell or else orbital. So this is called valence orbital or else a valence shell. Okay, valence shell. So this electron is called valence electron. Okay, valence electron. Students, you have to note down everything. Okay, so valence electron. Now students, so what I have to do? What I have to do? I have to study screening effect. Okay, I have to study screening effect. Okay, so or else a shielding effect. So what I mean by screening effect or else a shielding effect, that means, see, actually the effective nuclear charge in the sense here, the distance or else effective control or else controlling capacity of this nucleus on this valence electron. But what happens in case of D electron? In case of D, there are 10 electrons, and in case of F, there are 14 electrons. Because of that, what happens? See, if someone is sitting in the last bench, only one student is sitting in the last bench, and then here teacher is there. Imagine like this, and here more number of students or minimum 10 number of students are standing. So at that time, can teacher can 1 minute. See students, teacher is there here, okay, and student is sitting there in the last bench. Now the effective nuclear charge is in the sense the controlling capacity of this teacher on the valence electron. So now imagine that one electron is sitting, then in front of that one more shell is there or else one more bench is there, 10 number of students are standing or else a 40 number of students are standing. 10 is true for in true 10 is applicable for D, and 14 is applicable for F. So if it is like this, means if the situation is like this, means if they are there here in the last but one, then what happens? Teacher cannot see the last one. Okay, so therefore what happens to the effective nuclear charge decreases. That is because of the shielding effect. Students, I think this is explained, I think, correct? Shielding effect I have explained, right? Yeah. So now students, what happens is you just write this conclusion, then so you write screening effect. So that means, what do you mean by screening effect, students? With respect to the nucleus, the last electron. So imagine this is the last electron. Okay, this is the last electron. Pen is the last electron, and this hand is nothing but a shield. Okay, shield. So now you can't see my face, right? Correct. So it act as what is that? That hand act as a shield between the last electron as well as nucleus. Okay, so this, if this is so, then what about this is effective nuclear charge? Z effective nuclear charge is less. Therefore the last bench students usually they will write some other, if it is a chemistry class, they will write physics record, or else physics they will solve some maths problem. Why? That is because of a screening effect. Usually you can compare like that. Okay, yeah. So now you just write, students, a screening effect. Yeah, screening effect where effective nuclear charge, if you consider what happens, effective nuclear charge. Yes, so students, you have mic and you have to unmute and then communicate. Yes, what happens to the effective nuclear charge, students?
Decreases.
Decreases. Okay, decreases. So effective nuclear charge decreases means what happens to the screening effect? Screening effect is more. That is the meaning. Okay. So now students, what about the size? If screening effect is high, okay. So what about the size of an atom? Size of an atom, whether it increases
Increase.
or less. Yeah, it
Increases.
obviously it increases because effective nuclear charge is less. Is it clear, students? Then remaining variation we have studied, right? Along the period, how it varies down the group, everything. Students, you have to communicate. Correct?
Yes, ma'am.
Okay. If you take pause, then I will also take pause. If you communicate, I will communicate. Otherwise, yeah, it is difficult. Students, now using using this screening effect, you can explain the atomic radius of some d block elements. So students, I'll explain this one. So now students, actually what happens along the period, what happens to the size? General conclusion,
Size decreases.
size decreases because electrons are added to the same shell, correct? So now how this scandium as well as zinc are arranged, scandium to zinc along the period or else down the group?
Along the period.
See, along the period means you are expecting decrease in size, right? From scandium to zinc,
Yes,
is it
ma'am.
clear? Yes, but that variation is not uniform or else smooth. Okay, that one minute. Three students, from scandium to manganese, size decreases, no problem. After that, iron to copper, size remains almost the same. And what happens in case of zinc? Suddenly, size increases. So this is a variation which is observed because of this screening effect in case of D block element. Okay, I'll write the conclusion now. See, from scandium to manganese, size decreases. Size decreases. Then what happens? This is in a 3D series, okay? 3D series. Then what happens, students? From Fe to copper. This is from scandium to manganese. So this is from Fe to copper. So what happens to the size? Size remains almost the same. Okay, size remains almost the same. Then what happens in case of zinc? Zinc size suddenly increases. Now you have to explain this reason because in terms of atomic radius as well as effective nuclear charge and using the screening effect. Okay, students, what may be the reason why size decreases down the group or else along the period from scandium to manganese? What is the reason? It is known to you. What is that?
Electron are added to the same shell.
Okay, electrons are added to same shell. Okay, electrons are added to same shell. Electrons are added to, okay, so let me write all those points. Electrons are added to same shell. Electrons are added to same shell. Okay, if electron is added to the same shell, what happens to the Z effective? Effective Z effective means effective nuclear charge.
Increase.
Does not change because there is no shielding effect.
No, no, no. You just tell me what happens to the effective nuclear charge, whether it is less
It
or else more.
increases.
Yeah,
Increases.
effective, you just there only you write effective nuclear charge is more. Effective nuclear charge is high or else more. Effective nuclear charge is high or more. Okay. Effective nuclear charge is high means what happens to the size?
Decreases. Decreases.
So there only you write a size decreases. This variation is regular, right, students? So it is in actually we did a general concept generalization. So there also we wrote along the period size decreases because electrons are added to the same energy level or else shell and effective nuclear charge is high. Okay, so now what happens, I have to see scandium to manganese. So which electron is it? Last electron enters into which orbital, students? Very slow response. Last electron I gave one, this one homework, right? What is that?
3D.
Cesium, we had to write the electronic configuration.
Of what? From?
Cesium,
Huh?
F block element.
F block element. Did you notice that F block F electron enters into n minus 1 2 sorry n minus 2 level? Did you notice that? For example, if you case a lanthanoid series, if you consider lanthanoid element, then 4f something will be there and 5d electron will be there and 6s2 will be there. Did you notice that?
Yes, ma'am.
Okay. So most of the, okay, 1 2 3 answers are coming. Then like this, at least they are doing like this. Then remaining thing they are seeing like this. Remaining students. Okay. So now students, I'm asking, see, scandium to manganese, if you consider this one, this belongs to which group or else which block?
D
D
block.
That means the last electron enters into
3D.
d electron, d orbital. Last electron enters into d orbital. 1 minute. Okay, last electron enters into d orbital. Okay, so now what happens in case of a scandium? Students, in case of scandium you have d1 electronic configuration. Then after scandium, see, let me show this one now. See, 1 minute. Yeah, here students, in case of a scandium you have d1 configuration. In case of titanium it is d2 configuration. Vanadium is a d3 configuration. Chromium is nothing but d4 configuration. Manganese is nothing but a d5 configuration. But you can also have half filled configuration here. Okay, that is different. Leave that. So that means here last electrons are added to d orbital. So totally how many electrons can be placed in case of a d orbital? Total 10 electrons can be placed. So when you keep, and then okay, before that let me write the electronic configuration of some, 1 minute. So let me concentrate on the electronic configuration of cobalt. It is actually 27 and electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d7. Students, 4s2 is the last highest value. 4s2 is the highest value. Means with respect to the nucleus, 1s is there here, 2s, 2p is there, 3s, 3p is there. After that, you have a 4s. And then 3d actually it comes inside usually. Okay, so the highest value of n is equal to 4 here. Highest value of n is equal to 4. Okay, the last electron enters into n minus 1 orbital, that is equal to d. Okay, so how many electrons are there? Total 7 electrons are there. You can place 1 to 10 electrons in that situation. So now students, you just concentrate. So this is a nucleus, this is 3d and this is actually the last one, that is 4s2. So now electron will be there here, but here how many electrons are there here? Total 7 electrons are there. These 7 electrons shields the outermost one, because it screens, it acts as a block between the nucleus as well as the outermost electron. Okay, so what happens here? Directly you write screening effect in this case. 1 minute. Yeah, students, here you write d1 to d5 system. D5 system size is nothing but d1 to d5 system. Here you write, students, effective nuclear charge. Effective nuclear charge is also considered as Z effective. It is always greater than the screening effect. That is, S is nothing but a screening effect. Okay, 1 minute, students. You write all these things. Yes, students. Here, from scandium to manganese, size decreases. Okay, from scandium to manganese, the size decreases. Students, turn on your camera. Turn on your cameras. I had some urgent work. Then what you had? Huh? Very good, students. Okay, so students, here from scandium to manganese, the size decreases. Why size decreases? Always remember, size is mainly because of effective nuclear charge. If effective nuclear charge is more, then size automatically decreases. But students, here 1 electron are added. See, from scandium to manganese, if you consider, in scandium 1 electron is there. So see, students, so this is like this. Last 1 electron will be there. So this is the block, okay, D, okay, this is the D, 1 minute, yeah. This is D now, okay. So this is the valence electron. So now 1 electron is added to this in case of a scandium. Nucleus is there here. Okay, so this is the nucleus, this is a d orbital, and this is the valence electron in this case is nothing but a s electron, that is 4s or else 4s2 or else a 4s s electrons, you can take like that. Okay, so now to this one, add 1 electron, add 2 electron, add 3 electron. What happens, students? Slightly screening effect increases. Is it clear, students? Are you able to follow? See, students, you take this one only. Okay, so now the last bench electron is there, last bench, only 1 electron is sitting. Okay, at that time, see, sorry, last but one bench, if you consider, no electrons are not there. Okay, electrons are not there. So now you can explain the radius using z effective concept. Z effective in the sense, it's a effective nuclear charge. Now nucleus is there here, and last electron is sitting there, and you add one more electron here. What happens now? One extra shield is there. Okay, so but is not that much effective. Add 2 more, students, add one more one more. That is nothing but, from scandium to manganese, you can add 5 electrons. See, now like this, 5 electrons are there. Can you see this one pen? Pen is nothing but, okay, so these 5 electrons are there, sorry, like this. Okay, 5 electrons are there. Can you see this pen now? Pen is nothing but valence electron now. You can see, right? Okay, you can see, but still effective nuclear charge is there. So here size decreases because, from scandium to manganese, the size decreases because effective nuclear charge is more than that of the screening effect. Students, can you explain why size of Fe, size from Fe to copper, it remains almost same? You have to consider Z effective as well as screening effect to explain this. Can you explain why it remains the same, when it remains the same? Yeah, Suman, correct. Okay, so 1 minute, what is this question? The screening effective and Z effective are almost equal, correct? Say, ma'am, does the valency of the electron of the metal escape when does the valence electron of metal escape when electricity is passed through them? Yes, valence electron escapes when electricity passed through them. Amit, you asked this question, right? You once again, you remind me. I will explain this. After that, I will explain that. Okay, but you have to ask. Don't send once again. Don't send message. You unmute and then you can ask it later. Okay. So I will explain when it is when it will escape and when it will be absorbed. Okay. Yeah. So now coming to this, students, here size remains the same, almost the same. So what happens actually? Here also electrons are added to the same energy level. Correct, electrons are added to same energy level. There is no variation in the first point, the same point. And what about the effective nuclear charge? Effective nuclear charge, what happens, students? Electrons are added to same energy level along the period. Effective nuclear charge increases. Correct? Effective nuclear charge is there. Effective nuclear charge increases. But what happens, students? You are adding one more extra electron. Now, this is from D6 configuration to D9 configuration. So in case of D, I have already informed you that you have to put 5 boxes. So you place 1, 2, 3, 4, 5 electrons here, and then 6th one is to be paired here. Okay. So what happens actually? See, 5 electrons like this. You can see this pen now. Okay. Keep one more electron here. What happens? This gap is filled. Okay, keep one more electron here, that is gap is filled, but still these two gaps are there. So therefore you can place total 10 electrons in that D. If you place 10 electrons in that, or else you just keep 9 electrons, because copper is there, right? The copper is nothing but D9. So you keep 9 electrons like this. So what happens to the gap? It means it's completely paired, right? Electrons are completely paired, right? Only one gap is left. Okay, so now what happens to the screening effect? Screening effect slightly increases from where? From manganese. Okay, screening effect slightly increases from manganese, students. And now in this case, Z effective is there, right? Effective nuclear charge almost it is equal to, okay, it becomes equal to the screening effect. Okay, effective nuclear charge is almost equal to screening effect. It becomes equal. So therefore size remains almost the same. Size remains almost the same. Size remains almost the same. So now students, can you tell me why zinc size suddenly it increases? Which one is a predominating force? See, from manganese, yeah, correct. See, from scandium to manganese, Z effective is the predominating force. Screening effect is not that much, okay, it is less. But in case of iron to copper, screening effect as well as the Z effective, it balances each other. Then what happens, students, in case of zinc, suddenly you are increasing the number of D or electrons, so the configuration is D10, all gaps are filled. Okay, all gaps are filled. So what happens, students? The effective nuclear charge increases. So all gaps are filled like this. So you can't see the pen now, or else the last electron, you can't see this one. See, pen is there here. You can't see this one because all gaps are closed here. Okay, all are paired. What happens if it is paired? At the time, can you see my eyes now? Can you see my eyes? You consider that eye as a, okay, you consider this eye as a nucleus. Okay, eye as a nucleus. Now you can't see. That means nucleus cannot control this one. The pen is nothing but the valence electron. Can it control? No, because of the presence of the shield. So what happens? See here suddenly screening effect increases, predominating effect than that of the Z effective. Okay, so this is the variation, or else this variation that is in presence of in case of a 3D. Okay, so size is not actually according to the rule along the period. If you consider, size must decrease because effective nuclear charge increases, but that there is an exceptional case in case of D block, so that too in 3D as well as 4D series. So what happens actually? So from scandium to manganese, size goes on decreases because here effective nuclear charge, Shashank, effective nuclear charge is the predominating force than that of the screening effect, then from iron to copper, both will balance. Okay, effective nuclear charge as well as screening effect balances with each other. Okay, so therefore size remains almost the same. And what about in case of zinc? Since you are adding extra electron, so D reaches to its maximum limitation, that is D10. So more number of electrons are there like this. It will block the outermost electron from the nucleus. When it blocks the outermost electron from the nucleus, effective nuclear charge is almost zero, you can say, or else it decreases. Okay, so it decreases. So therefore screening effect increases. So the valence electron, last electron, it can move anywhere. So therefore what happens to the size increases. Is it clear? Is it clear? Yes, students. Now 1 minute before coming to this Amit's question, let me explain. See how to calculate Z effective. 1 minute. Yeah, one more calculation set is given. So how to calculate Z effective of anything? any element. So Z effective can be calculated by subtracting the atomic number by screening effect. Okay, you have to. So what do you mean by Z? Z is nothing but atomic number, and this is nothing but the shielding effect or else a screening effect. Screening effect. Is it clear, students? So if any metal is given, you can calculate like this, but this screening effect for this different calculation method is there. Screening effect for S as well as P, D, F, it is different, students. Now, if I want to remove some electrons, see this is a nucleus, and imagine this is a S orbital, this is a P orbital, this is a D orbital, and this is F orbital. Now the question is, from which orbital it is easy to remove electron? Important. So you have SPDF. So from which orbital it is easy to remove electron?
F orbital.
F orbital.
Why F from F orbital?
Because there are many electrons and there is electron-electron repulsion.
Okay, many electrons are there. Electron-electron repulsion is there. Okay, but one more thing is very important. What is that?
SP
Far
and
from nucleus.
effectively shield F.
Yeah, what?
The SPD orbital shield the F orbital.
Okay, that is also okay. But the thing is, whatever it may be, very simple or else a very important basic concept is there. What is that? The distance. You just concentrate on the distance now. Distance between the nucleus as well as S, nucleus P, nucleus D, nucleus F. You just compare and then tell me the answer, proper answer.
It is farthest from the nucleus.
Yes, so farther from the nucleus means what happens actually?
Atomic radius
Effective nuclear charge decreases.
Yes, yes. Effective nuclear charge is less, students. Okay, effective nuclear charge is less because it is far away from the nucleus. Okay, it is far away from the nucleus. You can remove electron easily from F. What about from S? This is very close to this nucleus, so therefore removal of electron is not that much easy. Okay, removal of electron is not that much easy. Muralidhar, what happened to your camera? So removal of electron is not easy, not that much easy, students. Now I can say electron removing capacity. Okay, let me remove this. Electron removal or else removing. So you take S, P, D as well as F. So it is very difficult to remove electron from S, but it is little easy to remove electron from P. It is very easy to remove electron from D, as well as it is very easy to remove electron from AF. Okay, so this is the electron removal capacity. Okay, removing nature or else order. Over. Okay, students, then some more important points I have to remember or else I have to study. See, students, let me concentrate. See, now we have studied atomic radius, its variation, how it varies along the period as well as down the group. It is over. Okay, so let me take the second variable. Let me take a second variable that is nothing but metallic property. So any variable, if I consider, I have to study it in the periodic table. So you just write a variation of a metallic property, variation of metallic property in periodic table. Variation of metallic property in periodic table. See, students, if they give periodic table, then what you have to do, students? Periodic table, it contains two things, that is nothing but one is period and one more is group. Correct? Now you consider this along the period, how it varies, you have to write that one, and how it varies down the group. Two things you have to write. Students, I'll show you the periodic table now. Students, the thing which is there here is metal, and the metal which is the elements which are there here is a non-metal. So now, how metallic character varies along the period? Students, can you generalize this?
Left to right it decreases.
Left to right it decreases in the sense along the period. If you consider along the period, so what happens? Metal is converting to non-metal. So what happens to the metallic character? Metallic character decreases, non-metallic character increases. Then exactly opposite, that is nothing but along down the group. So down the group, what happens, students? Usually exactly opposite to that of the period. What is that? Here
Decreases.
it increases. Then the third point, let me study it as a non-metallic character. Non-metallic property. So once again you study variation of a non-metallic character, variation of non-metallic property or else character in periodic table. See students, along the period what happens to the non-metallic character?
Increases.
Increases.
Yes, you're right, it has increases. Then down the group what happens to the electronegativity, non-metallic character?
Decreases.
Non-metallic character, it is opposite to that of the metal, that is decreases. Non-metallic character, it decreases. Okay, did you write all these points? One minute. Yes, students, the next one is related to the reactivity. Next property is related to the reactivity, students. Reactivity.
You said about that question.
Okay. So, yes. You write that as a reactivity, okay? Yes, what was that question? 1 minute, let me check. Where is that message now? Yes. His question is nothing but, does the valence electron escape from the metal when you apply electric current? Yes. See, you take a sodium now. Don't write. Okay, this is just a clarification. Sodium is a metal, right? So what is atomic number? Atomic number is equal to 11. Write the electronic configuration. It is 1s2, 2s2, 2p6, 3s1. So now you apply energy to this, maybe electrical or anything. So now what happens? There exists a shifting. Okay, so this will jump. Okay, this will be liberated from the system. So students, in your lower classes or else in 10th or else 9th, did you study anything related to photoelectric effect? Did you study anything? Do you know anything about photoelectric?
Yes, ma'am.
Okay, photoelectric effect means what? So you will take some surface and you pass a light of particular frequency to this. At that time, okay, pass a light of a particular frequency to this. Then what happens? Some electron will be ejected from this, right? Why? That system electron which are there on this absorb radiation and it will be ejected. So same thing will happen here. Okay, why it is so? So in case of sodium, atomic number is equal to 11. See, if you apply energy, it easily donate that last electron and its electronic configuration will be like this. Ns to 2p6. Since one electron is lost, so you can write it as Na plus 1. So why it donates one electron? Because see, this sodium can donate one electron. Sodium can donate one electron and it can attain a noble gas configuration. Okay, it can attain noble gas configuration. Now you just take the count, students. Here 2 plus 2 plus 6. So total 10 electrons are there. 10 electrons means what? Which element it is?
Neon.
Neon. Okay. Yeah, neon. Neon is a noble gas. Students, I'll show you the. Yeah. Students, 1 minute here. See, sodium is there here. Its atomic number is 11. See, this is the you have to concentrate on the previous element. Previous noble gas. Previous noble gas is nothing but a neon. See, always this will liberate one electron. See, always all group number 1 element liberate one electron to attain noble gas configuration, and all second group elements liberate 2 electrons to attain noble gas configuration. Why it attains noble gas configuration? Because it is a stable electronic configuration. Stomach is full. Correct? Stomach is full, or else you can also say number of electrons, atomic orbitals. Okay, S as well as P. It is completely filled. Correct? Completely filled. So when stomach is full, do you feel that if you means eating something, some extra thing? Okay, some exceptional cases may be there in a human being, but it is not there in chemistry. Okay, so did you get the point? And this is in case of metal. What about in case of non-metal? Students, you take this one. I will explain this. Okay, you take this last group element. So these are all non-metals, right? Right? Fluorine, chlorine, bromine, iodine. These fluorine, chlorine, bromine, iodine, they does not liberate any electron because it is nearer to the noble gas. One thing, it gains one electron to attain noble gas configuration. Is it clear? Okay, is it clear? But what happens in case of non-metal? This is a general conclusion. I will explain here. See, always metal liberates one electron to attain a noble gas configuration. Noble gas configuration. Students, we have studied electronic configuration, right? Along the period, down the group, everything is over, right? No response only. Shall I take a rest then? Did we study something related to electronic configuration?
Yes, ma'am.
Yes.
You communicate, then see, if you keep quiet, I'll keep quiet, so that I'll, after engaging 2 classes, I'll say, okay, portion is completed, read, attend the test, and then go for discussion. Okay, so let me start the second one. Within 1 days, I can complete my volume 2 chapters, chemistry, finished. Okay, so now students, yeah, now you take a non-metal. So non-metal, so for this you have to add 1 electron, plus 1 electron to attain noble gas configuration. Noble gas configuration. All elements try to, maybe metal or else non-metal, they tries to attain a noble gas configuration because it is a stable electronic configuration, that is because of completely filled electronic orbitals. Is it clear, students? Amit, did you get the answer for this? Yes.
Yes, ma'am.
Okay. Now where we are?
Reactivity.
Okay, reactivity. So now you have to study 4th variation, right? Yeah, reactivity in a periodic table. reactivity of metal as well as non-metal in periodic table. You consider metal. Consider metal. So what happens to this metal along the period? Reactivity of metal along the period. Students, what happens?
It decreases.
Is it very difficult to say something?
Decreases.
You just recall this concept. Students, I gave one more homework, right? To study elements from 1 to 30. Did I give that? Did I tell you that?
Yes, ma'am.
Yeah. You will laugh now. Correct, Anika? Yes, because you don't know. You know. Okay, what is what is a element having atomic number 26?
Continuously, I know, ma'am. Like,
Oh no, you have to tell. If I see continuously, they will not give continuously. Continuous element in exam. Okay, they will pick something and they will never give the atomic number to you. Yeah. Next time I will ask. Okay. Yeah. What is this? This is not related to us. Okay. So reactivity down along the period. So I'll explain this. So students, you take this lithium as well as sodium. Which one is more reactive? You have studied. Even in volume 1 also you have
Lithium.
studied.
Lithium.
Lithium.
Lithium. Okay. Sodium as well as potassium you to consider.
Potassium.
potassium.
Here it is lithium. Here it is potassium.
Sodium.
Yeah. First it is sodium.
I have asked 2 questions. So in this first one, what is your answer? Second question. For that second question, what is your answer? Leave that. In volume
First
1,
one
what?
lithium and second one potassium.
In volume 1, what you have studied, students? You have to store that sodium under kerosene. Why? Don't you have any other work?
It
reacts with oxygen.
Why it reacts?
Because it's
It
more
is highly
reactive.
It
reactive.
wants to become stable.
Once if it reacts with oxygen, it becomes stable. Chirag? See that actually even lithium when it reacts with oxygen it becomes stable. Even potassium when it reacts with oxygen it becomes stable. Or else you take any element when it reacts with the oxygen it becomes stable according to your clarification or else your answer.
Not like that, ma'am.
Then tell me. Yeah, someone is talking but it is not clear to me.
Ma'am, sodium is more reactive than lithium.
Why? So,
Because
okay.
reactivity increases along the...
See students, when surface area increases with respect to lithium sodium size, what about the sodium size?
It's greater than that of
Okay.
lithium.
So always remember when surface area increases, reactivity is also more. Remember this. Surface area increases means reactivity is more, one thing, and you're storing that sodium under kerosene. That is because sodium is more reactive. Okay. So always can you generalize now? Can you give a generalized statement regarding to the reactivity of metals now? Down the group, what happens?
Reactivity.
It goes on increasing.
Yes, now you're right. The reactivity down the group, it decreases. So what happens along the period then? Decreases. This is increase. Sorry? Down the group, what happens actually?
Increases.
Down the group, it increases. Down the group, it increases. And along the period, it decreases. Students, what about the non-metallic character? Reactivity of non-metal? Same thing. Okay, same thing in the sense actually reverse to that of the metal. Okay, so leave that. So the next one you connect it one into density, general statement. Okay, density is nothing but the see students, now here one pen is there, here one mobile is there. Can you see this one? Which one is more denser?
Mobile.
Mobile is more denser. Why?
Metal.
Metal. Okay, so you can't compare like that. Okay, so you take hydrogen as well as oxygen. Which one is more denser?
Oxygen.
Oxygen.
Why?
Mass per volume is greater in oxygen
Why you have calculated mass per volume and all?
because density is equal to mass per volume.
Okay, mass by volume. Density is equal to mass by volume. Okay. So students, here you consider, for example, hydrogen, its mass is 1, oxygen is nothing but 8. So why you have written it as, oxygen mass is nothing but 16. Okay. So it's almost double than that of the atomic number. It is 16. So why you wrote it as 16, students? No answer. Why the mass of oxygen is 16 than that of the, see, you take hydrogen as well as oxygen. Mass of hydrogen is 1. Mass of oxygen is 16. Why? What is the meaning?
More protons and neutrons. Damn.
Okay, protons as well as neutrons. So one thing, and students, see here, except this hydrogen. Hydrogen is the simplest one. It contains only 1 electron, and there is 1 electron is there, 1 proton is there. Okay, and no neutrons, 0 neutrons. Okay, but in case of this one, 8 electrons are there, 8 protons are there, 8 neutrons are there. So students, number of electron is very important. Correct? Number of electron is, if it is equal to 1, then what happens, students? Density is less. If number of electron increases, density increases. Students, I'll write the generalized thing. So write density. Density is directly proportional to the number of electrons. That means number of electrons increases. Number of electron increases, at that time the density also increases. Density also increases. So vice versa, that means number of electron decreases means what happens to the density? Density decreases. Is it clear? Is it clear? Okay, so the next variable is nothing but melting point. Write it fast. Melting point. So melting point, actually here, melting point, once again it is related to density. Okay, melting point is related to density. Density is related to number of electrons. So can you tell me now what happens if I increase the number of electrons? What happens to the melting point of this element?
Melting point increases.
Yes, you write the conclusion. Conclusion is like this: melting point increases. Did you get the point, students? See, melting point is related to density. Density is related to the number of electrons here. But in your physics, we are writing it as mass by volume. But here we are considering or we are explaining that density in terms of electron. Okay. If more number of electrons are there, density increases. Okay. Increase the number of electron. So that means you are increasing the density. That means you are increasing the melting point. EMP is nothing but melting point. Is it clear, students?
Ma'am, but non-metal is having low melting point than the metal.
Not everywhere. You have to specify which metal, which non-metal.
Ma'am, in this, chlorine is having minus 101.
Yeah. So chlorine as well, that means the 17th group, if you consider, the nature is gas. And remaining thing, if you consider, for example, if you consider a semi-metal, in case of, see, just check here, in case of P also, P is nothing but here. So you have a metalloid section. See, and here only you have studied in the first chapter, metals and non-metals. So these two are exceptional cases. See, you can see the crystalline nature. Even though 17th group elements are gases, iodine will show solid structure. Correct. And what about this bromine, chlorine, fluorine? It shows a gaseous nature. Okay, gas. Physical state is gas. So now at that time, what happens? Melting point increases for this iodine. Okay, increases for iodine. So usually in chemistry, melting point as well as density is related to the number of electrons. Okay, is related to the number of electrons. If number of electron is more, then density is more. Melting point is also more. Is it clear?
Yes.
Okay. Students, the next thing is my favorite topic, that is nothing but ionization energy. Did you write all these points? Okay. This is the third main variable. I think this is the sixth one, right, students? Sixth or fifth? Seventh?
Seventh.
Okay, but actually this is a main. After atomic radius, you have to study this one. So you write the main energy, variable, that is nothing but ionization enthalpy, or else it is also called ionization energy. It is represented by the symbol IE. And it is always endothermic process. Students, remember all these things? Endothermic means the sign is always positive. And it is measured in terms of kilojoule per mole. Write all these things now. Stay, students, I got one special species here. That is nothing but Sai Pratiksha, Satvika, Sai Pratiksha, and one more thing is Sashank V. Pujari. No, Sai Pratiksha. So now what is the total participant strength now here? Total 30 means 29 students are there. Okay, Sai Pratiksha, no problem. But I'll give this example so that it is easy to understand. Okay, before that, let me give a definition first. Ionization energy means what? Ionization energy is nothing but a minimum amount of energy, right here. Minimum amount of energy required to remove valence electron, write it full, okay, valence electron from isolated neutral gaseous atom. This is the definition of ionization enthalpy. It is a minimum amount of energy required. Students, here this word is very important, minimum amount. And energy required means you have to apply energy, means the process is nothing but endothermic. Okay, process is nothing but endothermic. So charge is always, energy charge is always positive. So students, what is this definition? You read this: minimum amount of energy required to remove what? To remove valence electron. From where? From isolated. Okay, it's actually completely separated. Okay, is not in contact with the other isolated neutral gaseous atom. So usually you can remove something easily from gas because the attraction is less. Okay, solid, if you consider solid, atoms are closely packed, and if you consider liquid, so there is a slight gap, and in case of gas, that gap is very large. So you can easily remove electron from gaseous state. 1 minute, let me check participant now. Oh yeah, see this Anish is there, right? His video is off now. And one more species is there, that is Sai Pratiksha. And one more, two species I got now. So now what I want to do, I have to apply this knowledge of ionization enthalpy or else energy. So what is this, students? It is a minimum amount of energy required to remove what? To remove that Sai Pratiksha because her video is off. Correct? So let me remove one molecule out. What about the size of this class? Strength decreases, right? Strength decreases. If you remove one electron from the system, what is observed, or else which ion is formed?
Cation.
Cation is formed. Okay, let me remove that Sai Pratiksha now. 1 minute. Yes, Sai Pratiksha. Once again, your video is off. Okay, so let me apply ionization enthalpy on you now. So now, just for your information, the size is 29, means actually 29 participants are there. Let me remove one, that is Sai Pratiksha. That means let me remove one electron. At that time, what happens to the size? The size decreases. Now, the nucleus or else teacher has to control only 28 students. That means ionization in the sense you have to remove at least one electron to prepare ion. So students, don't write this one. So you just write X is a neutral gaseous atom. You have to write the physical state of the element. So that is nothing but X. X is nothing but, it's a gas, physical state is nothing but gas. Now students, you apply minimum amount of energy to this X. Remove one electron. Okay, let me remove one electron from the system. Now tell me, what is the charge of Ex? What is the charge of X? X plus, what is the physical state? Physical state is gas only, students. Now, the energy required or else energy which is applied here to remove that electron is called ionization enthalpy, IE, ionization energy. So I have removed only one electron. Correct? I have removed only one electron. What happened, Sai Pratiksha? Now video once again completely. Yeah. Students, X in gaseous phase. So you take this gaseous atom, apply energy, minimum amount of energy is to be utilized to remove the electron. Remove one valence electron and you are going to get a cation. Okay, and you are going to get a cation. Okay, Pratiksha. So remove one electron and you're going to get a cation. So now tell me, students, with respect to the parent atom, this is a parent atom. So now this is a cation. What about the size of the cation, less or more with respect to the parent atom?
Decrease.
Small, decreases, correct? Small, because you have removed one electron. See, when 29 participants were there, at that time teacher has to concentrate all 29 participants. Okay, if I remove one electron, then total participant is equal to 28. That means the teacher has to control only 28. So what happens to the size? Size decreases. If you remove one electron, then you are going to get a cation, remember. Okay, yeah, this is nothing but ionization energy, students. Now this ionization energy is also called first ionization energy. There only you write, here only you write. This is called first ionization energy. Okay, this is called first ionization energy. Why first ionization energy, students? Can you define that? Because I have removed one electron. If I remove one electron, then it will be a first ionization energy. If I remove second electron, then it will be second ionization energy. If I remove third one, then it will be a third ionization energy. And if I remove nth electron, then it will be a nth ionization energy. Is it clear? Is it clear? I have removed only one electron here, so therefore it is a first ionization energy. Is it clear, students? Yes. So now let me write one more equation. Students, let me repeat that. This is X, neutral gaseous atom. Apply energy to this. You are going to get X plus, that is gas, and one electron is removed. Energy utilized in this case is called first ionization energy, and it is calculated, and its unit is kilojoule per mole. Kilojoule per mole. Over. This is about the first ionization energy. Now I want to remove one more student from this class. Let me check. Okay. Yeah. No. All are proper. Okay, so now let me remove one more species. Yeah, now see, all are proper. Why? Because I have already announced that I will apply ionization enthalpy concept on you.
The atom has become stable.
Atom, no, it's not at all stable. Okay, why? Okay, so you, Muralidhar, you explain, no? Why it is stable. Okay, so any other idea or any other proper reason for that?
Effective nuclear charge is more.
Yeah, now effective nuclear charge is more because size decreased, right? Correct, size decreases. One thing, when size decreases, see, I have already announced that I have already removed Sai Pratiksha, but not yet. Okay, but I have announced like that. So therefore, if I check participant list now, see one more. Okay, someone went out. I think Sai Pratiksha only. She left. I did not throw her. Okay. So now, see, she went out. Correct? What happens to the size? So you just concentrate on the participant list. It is only 27. Size decreases. Now I have already announced that I will throw you out if you keep your video off. This is the announcement. Then for at least for 5 minutes, like Medanash, see, now he just turned on, I guess. No? Okay. So at least for the after announcement, at least for 5 minutes, you will keep your videos on, right? Now, to remove one more species from this situation, what I have to do? See, Sai Pratiksha came 1 minute. Yeah. To remove one more electron from this system, now I have to apply lots of energy. Correct. I have to apply more energy to remove electron. See, I can also remove Shashank MN now because he is talking. Correct? He is talking. His video is on, but he is continuously talking. So I will remove that electron. So now since he is talking, I will apply little extra energy. His camera is on, but he is talking. Okay. With respect to that first electron, see, to remove one electron, see, 1 minute. See, this is the size of the atom. You have removed one electron. So what happens to the size? Size decreases. What happens to the effective nuclear charge now?
Increases.
Increases. Now students, the question is, you have to remove the second. Okay, so before that, you have removed one electron, right? One electron from this, right? So energy utilized to remove that electron is called?
Ionization energy.
Yeah, can you mention that? Which ionization energy?
First
First
ionization.
ionization
First
energy.
ionization energy. Now students, I have to apply little extra energy to remove the second one. Why? Because size decreased, right? Size decreases means effective nuclear charge. What happens to the effective nuclear charge? Effective nuclear charge. Muralidhar, see here, I can throw him out because he is talking with someone else. Yes. So now see, size decreases means effective nuclear charge is increases. Effective nuclear charge increases. Effective nuclear charge, if it is more than effective nuclear charge, if it is more, can I remove that electron easily? Can I remove? No, it is difficult. Okay, but I want to remove one more electron from this system. Okay, now the question is, from where I have to remove second electron? From X or else from X plus?
X plus.
X plus.
Is it, why it is not from X?
We are removing electron from the decreased sized atom.
Yes, students, and now you have to take X plus and apply energy and remove one more electron. Now what is the charge of the X?
2
Two.
plus.
2
Yeah,
plus.
this is 2 plus. Now this ionization, this energy required to remove one more electron is called, this ionization energy is called what?
Second ionization.
Second ionization energy. Suppose if I want to remove, see students, this is also possible. Okay, so if you have X, you apply lots of energy. You can apply more number of, you apply energy, particular energy, and you can also remove 2 plus, means 2 electrons are removed at a time. So this is also possible. Okay, this is also possible. In higher class, you will study how to write that oxidation, reduction, everything. Okay, students, and now the thing is, if I remove nth electron from the system, what is the ionization energy? If I remove
nth ionization energy.
if I remove the last electron, I don't know which one, so I'll keep that electron as a number En. So energy required to remove nth electron is nothing but nth ionization energy. So now students, one more confusion is there for me. So which one is great? First ionization energy is more, or else second ionization energy is more?
Second
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 ionization.
ionization.
Why second ionization energy is more?
Because effective
effective
nuclear charge is
nuclear
more.
charge increases.
Okay, in first ionization energy, the Vivek, size decreases, right? Size decreases. What about the second ionization energy? You have to remove electron from the smaller atom now, smaller atom, correct? So now what happens? Size automatically, automatically size. Yeah, Vivek, I can apply third ionization energy on you. Correct? Yeah. So now size decreases. See what happens to the third ionization energy now? Because I have already applied more energy to remove second. Now I have to apply little extra energy than that of the second to remove the third electron. Correct? Always, can you give the generalization now? So you write here, particularly you write, second ionization energy is always greater than the first ionization energy. Or else higher ionization energy is always higher than that of the lower ionization energy. Higher ionization energy, you can write it as nth ionization energy is always, or else you can write like this, nth ionization energy is always greater than n minus 1 n minus 1, okay, ionization energy. So these are all the general conclusions. Over? Over? Okay, ionization energy concept is clear, right? Clear, right? Okay, now I have to study ionization energy, how it varies in the periodic table. Right, variation of ionization energy, write it. Variation, 1 minute. Variation of ionization energy in the periodic table. In the periodic table. Variation of ionization energy in the periodic table. See students, the periodic table means what I have to do? I have to study two things. What are those? One is along the period and one more is down the group. See students, so many of them kept their videos off. Since I'm there in ionization enthalpy, I will remove you out, students. Then later if you call also, that call comes to me only, no problem. Okay. So coming to this ionization energy, variation of ionization energy in the periodic table. See, first let me study something along the period. So to study, see, ionization energy depends upon size. Do you agree? Do you agree? Yes, Saujanya. Do you agree? Yes. See, first what you have to do, you remember atomic size. Atomic size. How it varies along the period? How it varies along the period?
Decreases.
Yeah, it decreases down the group.
Increases.
Increases. Okay. So then remaining all variations like ionization energy, electronegativity as well as electron gain enthalpy are these four are four main variables. Then comes metallic character, non-metallic character, reactivity, everything. Okay. So atomic radius, ionization radius, ionization energy, atomic radius, ionization energy as well as electron gain enthalpy as well as electronegativity are main four variables. So it is actually exactly opposite to that of the atomic radius. Okay, along the period you write the size variation. So students, before that, what happens to the electron, students? Take rest. Okay, let me take rest. What students, what happens along the period? Electrons are added to?
Same shell.
Okay, so right then. If you take rest, I will also take rest. Okay. So now you write electrons are added to same shell. Okay. If electrons are added to same shell, then what happens? What's your problem? Electrons are added to same shell. So what happens to the size?
Decreases
Decreases.
Size decreases. Why?
because electron are added to same shell.
Yes, I have written that already. Electrons are added to the same shell, so therefore size decreases.
Nuclear charge is
Yes.
high.
Yeah, if you write the first sentence so many times, I will not give marks, okay? So you write effective nuclear charge. What happens to the effective nuclear charge?
Increases.
Increases.
Effective nuclear charge increases. Okay. Effective nuclear charge increases means what happens to the size? Size decreases. Size decreases means what happens to the ionization enthalpy? You have to remove electron. Size is less. Effective nuclear charge is more. What happens to the ionization energy now?
More.
So
Increases.
there only you write ionization energy increases along the period. Then the next general conclusion, down the group. Yes, tell me, same point.
Ionization energy decreases.
No, I have to start it from the beginning. What is that first
Electrons are
statement?
added to different shell.
Yeah, right. Electrons are added to different shell. Electrons are added to different shells. Okay, so no problem now. What happens to the next effective nuclear charge?
Decreases.
Effective nuclear charge decreases. What happens if a charge decreases?
Size increases.
Size increase.
Size increases. So what happens to the ionization energy?
Decreases.
See, electron is there, somewhere there. So you come from that side and pick that electron out. So that means a little amount of energy is sufficient because the effective nuclear charge is less. So what happens to the ionization energy now?
Decreases.
Decreases. Students, this is the general variation. Over. So as I said, see 1 minute, let me check a participant list once again. Sai Pratiksha is there, Shashank V. Pujari. So these are all the species, you can't repair them. Same thing is there in chemistry. Okay, same thing is true in chemistry. If you generalize the rule that ionization energy must increase along the period and it decreases down the group, but there are some species, they born to break the rule. Okay, let me study those species. So the first one is nothing but a noble gas. Noble gases. What happens to the ionization energy of this noble gas? What is the electronic configuration of noble gas? General electronic configuration is NS2NP6. Is it true?
Yes.
Yeah, NS2NP6. Now what happens, students? To remove electron, what do you mean by ionization energy? Ionization energy means minimum amount of energy is required to remove the valence electron. So now the electrons are, means s orbital as well as p orbitals are completely filled. So therefore, to remove one more electron from this, you have to apply very high energy. So therefore, you write ionization energy of noble gases are very, very high. But actually it increases along the period. So in the corresponding period, noble gas has high energy. Okay, no problem. But even down the group also, electronic configuration remains the same, right? Ns to Np6, you need to apply high energy to remove that electron. So ionization energy of noble gas is very, very high. Okay, no problem. One exceptional case because of completely filled electronic configuration. Now, another one more set is there that also does not obey general rule. So that is nothing but, students, you consider this. Name the element which is having atomic number 4?
Beryllium.
Beryllium.
Beryllium. Next, atomic number 5?
Boron.
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 This is atomic number 4. This is atomic number 5. So now beryllium as well as boron, how they are arranged?
S and P block.
No, along the period or else down
Along
the
the
group?
period.
Along the period. Is it clear? Is it clear? Then what is your general observation, students? In terms of IE, ionization energy, along the period what happens?
Increases.
It increases.
Ionization energy must increases, right? Yeah. According to your calculation, which one must have more energy here, beryllium or else boron?
Boron.
Boron, its ionization energy must be high, correct? Compared to that of the beryllium. Is it true? According to your calculation, but it will never show like that. Okay, students, you write beryllium, write its atomic number, write its electronic configuration, that is 1s2, 2s2. Okay, then write boron, you write atomic number, write its electronic configuration, that is 1s2, 2s2, 2p1. Students, now can you tell me the reason why, see actually, so here you write in practice or else actually ionization enthalpy of beryllium is high than that of the ionization enthalpy of boron. Why?
Because it is easier to remove electron from p orbital than that of s orbital.
Very good. See here in case of beryllium, nucleus is there and s orbital is there. S orbitals are maybe 1s or else 2s. S orbitals are nearer to the nucleus. Effective nuclear charge is more. But what about in case of a boron? So nucleus will be there here. Nucleus is there here. Okay, so then s will be there here, p will be there here. So p, its distance is more, so at that time effective nuclear charge is a little less than that of the beryllium, so you can easily remove electron. Is it clear, students? Here it is, s electrons are there, s electrons, it is nearer to the nucleus. Here it is little p electrons are far away from nucleus. Is it clear, students? Therefore, actually according to the general rule, boron must show highest energy for ionization energy, but beryllium shows highest ionization energy, that is because of p electron which is present in B, since it is present away from the nucleus. Okay, it is present away from the nucleus, so it is easy to remove that electron. Okay, so this is a second exceptional case. We have one more set. Okay, shall I rub this? Did you write all these points? Okay, so now let me take one more example, that is nothing but a nitrogen as well as oxygen. Nitrogen as well as oxygen. Okay, nitrogen as well as oxygen. What is the atomic number of nitrogen?
7.
7.
7. Atomic number of oxygen?
8.
8. So how nitrogen as well as oxygen are arranged?
Along the period.
Okay, along the period you write like this, along the period. So now what is your general conclusion?
Oxygen must have
Having the
Oxygen.
Along the period, ionization energy increases. So therefore, what is your observation? Ionization energy of nitrogen as well as ionization energy of oxygen, if you consider ionization energy of oxygen must be high according to the general rule. But actually it is not true, not true. Okay, actually or actual, what happens? Ionization energy of nitrogen is more than that of the ionization energy of oxygen. So once again you write the electronic configuration, students. So what is atomic number? It is equal to 7 and electronic configuration is 1s to 2s to 2p1. Sorry, yeah, 2p3. And what about here oxygen? 8, atomic number is equal to 8 and the electronic configuration is 1s to 2s to 2p4. Students, do you remember I told to put 1 box for S, 3 box for P, 5 box for D and 7 box for F? Do you remember that?
Yes.
Okay, in higher class, I think atomic structure, I don't know whether it is there to this in this volume there, or else in the higher class you are going to study different types of orientations, N, L, M, L as well as S value. So based on that you have to write. Okay, otherwise just you remember this thing, S orbital, spherical shape, you can arrange it in only in one direction. See, this is a S orbital. You can arrange this in only one orbit, one direction. Okay, so therefore you can write only one box. Now see, this is a p orbital. You can arrange this in three ways. So therefore you have to write a three box. And this is a d block element. You can arrange it in five different ways. So therefore you have to put 5 box. And this is a f orbital. So you can arrange that f electron or else f orbital in 7 different types. So therefore you have 7 boxes here. Okay. Here students, let me distribute the electron here. Okay, so is there any variation? 1s to 1s to same, 2s to 2s to same. Okay, 3p 2p3 is there here, 2p4 is there. So let me take the last one here, last one. So 2p3 in the sense, let me write 3 boxes, and here also p orbital, right? So let me write 3 boxes. Arrange those 3 electron, put 1 electron in this box, 1 more electron in this box, and 1 more electron in this box. Over, right? Then write the electronic configuration in this case, 1 electron here, 1 more electron here, 1 more electron. P3 is over, but it contains 1 more electron, that is P4. So you write like this. Now students, you just check and tell me, can you tell me the reason why nitrogen shows highest ionization energy than that of oxygen?
Because the paired electrons, they repel each other, so it will be easier to remove them.
Not at all.
Screening effect is more in case.
Not at all. That is also wrong answer. I told something to you when I think I have told the electronic configuration. It's not clear to me.
Orbitals are more strong.
Who is that? Who gave answer? Shashank Kemen. Okay, yes, that is the exact reason. See students, P3 is there. P3 is a half-filled. Okay, half-filled electronic configuration is a highly stable. Half-filled electronic configuration is highly stable. What about here? So one more thing is there, right? One more extra electron is there, but Muralidhar, it does not repel. So rippling takes place only when, see, suppose if this is a situation, if I keep 2 types of same type of, see, 1 electron if you like this is its charge is plus half. 1 electron if you write like this, sorry, you have to write like this, okay? So then its charge is minus half. So when you keep a plus half as well as minus half like this, then it will never repel. Suppose if you keep these 2 in this way or else in this way, then only it will repel. Is it okay, Muralidhar? Did you get this point?
Yes, ma'am.
So now you write, students, nitrogen is having more ionization energy, that is because of half-filled electronic configuration. Because of half-filled electronic configuration. Over. This is about the ionization enthalpy. Is it clear? Any doubt in this ionization enthalpy? Amog, do you have any doubt? No? No? Okay. So students, then I will study one more. I'll tell you one more variable about 1 minute. Will we get a break? Ma'am, isn't it a spin? Not charge. No, I did not get. What is this? They are half-filled. Okay. So many answers are there, students. Then why mic is there with you? You have to unmute and then you have to communicate. Now see, now I'm reading. So these are all the answers for, okay, the ionization energy. Something is related to ionization energy. Yeah, ma'am, that plus of as well as minus of. Yes, so what is this? Ma'am, isn't it a spin, not charge? Yeah, it is a spin. So that yes, actually n is there, L is there, ML is there, as well as EMS or else spin. Okay, it is represented by the symbol S. So here this spin is related to the electron. You can write electron like this. Okay, this is a up spin. Its value is equal to plus half. Okay, it is not at all related to the charge, it is related to the spin. It means plus half means you can conclude this as a clockwise direction, means spinning takes place in the clockwise direction. So now if you write like this electron, so then it will be a down spin. So its charge is, means the sign is minus half. So you can write it as anti-clockwise direction, anti-clockwise. See, in some other books, you will get this as a up spin electron. This is also true. You can write like this. Okay, you can also write like this, electron like this. Okay, or else you can write like this also, no problem. All are same, meaning same. Is it clear, Mithul? Now, students, let me explain electronegativity. Electronegativity. It is also represented by the symbol En. Right here, it is the capacity. It is the capacity of an atom to attract shared pairs of electrons towards itself. Electronegativity means it is the capacity of an atom to attract shared pairs of electrons towards itself. See, students, did you write this over? Shall I explain? Yeah, what do you mean by electronegativity? See, students, electronegativity is related to the capacity of an atom to attract shared pairs of electron towards itself. To attract means it is related to the gaining. Okay, it is related to gaining. To attract shared pairs of electron towards itself means it is related to gaining. Students, now whether it is related to the size, can you link this electronegativity to the size?
Yes, ma'am.
Yes, relate it. If a size is small, okay, now this is actually, the time is actually, Anika is asking from that time that whether she is going to get a break or not.
No, only once I asked for.
Only one, I'll multiply it by 10, no problem. Okay, so now what happens actually, so why she is asking, because this is a tea time actually, correct? Okay, so she has to eat something. Why? Because the stomach size is now, it is very small, correct? So now what happens to the gaining capacity now? Gaining capacity, it is more. If I give break for at least 3 minutes, so students will never return off. So usually I have experience, right, in volume 1. Yes, they will return off, means they will come after 10 minutes. Why? That is because of gaining capacity. Electronegativity, size of stomach is less, the same thing, you connect that stomach to atom, size of atom is less. So what happens to the gaining capacity? Gaining capacity increases. Now after eating some 2 or 3 plates, don't eat plates, something is there in that, right? So eat that one. After that, what happens to the size of the stomach? Increases, size increases. Now if I give one more plate of something to eat, will you eat it? Except exceptional case, okay, will you eat it? It is impossible. It is impossible. What happens to the gaining capacity then? Gaining capacity decreases. Is it clear, students? Okay, yes, always this chapter is very interesting one. You connect everything to either your school or else teacher, bench, classroom, etc., or else your stomach. To your orbitals are there, right? You can connect that one into your stomach. is easy to remember all types of variations. Yes, you connect that electronegativity to the size. Size is small in the sense gaining capacity increases. Gaining capacity increases. So what happens to the electronegativity then? Electronegativity increases. If size is big, gaining capacity, what happens to the gaining capacity? Gaining capacity decreases, electronegativity decreases. So what about other lecturers, whether they are giving break?
Yes, ma'am.
Another only 20 minutes left. Correct. So I think today it is not required. Correct. Let me, you check your gaining capacity after 6:30. Means you check your electronegativity at that time. Okay? Yes. Shashank, I'll throw you out because I can't give 20 minutes break. Okay, he's asking 20 minutes break. Impossible. Yes. So if you ask like this, Shashank, I will apply ionization energy concept on you. Yes, and now I want to study electronegativity in the periodic table. Write that. Variation of electronegativity in periodic table. Now consider period. So now you start it with size. So see, all are related to size. All variations are related to size. So now what happens to the size along the period?
Decreases.
Decreases.
Size along the period is decreases. Size along the period is small, decreases. What happens to the gaining capacity then? Electron gaining capacity. Electron gaining capacity in the science it is electronegativity.
Increases.
Electronegativity increases. Now students, you consider group concept. What happens to the size? Size down the group, what happens to the size?
Increases.
Size down the group, it increases. You know the reason why it increases as well as decreases. And increases means, size increases means what happens to the electron gaining capacity?
Decreases.
Electron gain capacity, that is electronegativity, decreases. Students, from the periodic table, can you tell me which one is the highest electronegative element? First rank holder in electronegativity.
Fluorine.
Chlorine, Cl.
Fluorine.
Fluorine.
Yeah, fluorine. So it is the size is very, very small. So its electronegativity is it's very high. Can you tell me second rank holder?
Fluorine.
Huh? No.
Chlorine.
No.
Oxygen.
It is oxygen. Okay, it is oxygen. Okay, first highest electronegative element in the periodic table is a fluorine. Second highest is nothing but oxygen. Do you you have to remember these two? Okay, yes. After this, once again we have to study exceptional cases. What happens to the electron gaining capacity of a noble gas? Noble gas.
0.
0. Electron gaining capacity of noble gas is 0 because completely filled stomach or else atomic orbital. You can't add extra thing to that. Okay. So gaining capacity is completely 0. Is it clear? Over. Then if you add one electron to the system or else if you remove one electron from the system. See, to remove someone from the class, see, this is Shashank V. Pujari and See, to remove Shashank M. Pujari, I have to go to participant list, means I have to waste my energy, correct? And I have to click on this, once again wasting of energy, and I have to click on more, and once again I will waste my energy, right? Then remove, once again wasting energy, correct? So that means this much amount of energy is applied on this to remove that electron. So that means it's actually utter waste of energy, right? So what is this? When energy, when electron is removed from the system, so if you want to remove one electron from the system, you have to apply energy, correct? Now someone will come, at that time also I have to apply my energy, that is I have to admit them, correct? So that means when electron is added to the system, I have to apply energy. When electron is removed from the system, at that time also I have to apply energy. Is it clear, students? So, but what type of energy? Energy may be endothermic or else may be exothermic. Okay, energy may be positive or else may be negative. So that I have to study now. Students, you have studied electronegativity, and there you said that you have to add one electron to the atom. It's a gaining capacity, correct? If you add one electron, then energy may be released or else energy may be absorbed. Is it clear? Is it clear? Energy may be released or else energy may be absorbed. Okay, so now if I study that energy, then it will be electron gain enthalpy. So the next variable is nothing but, you write electron gain energy or else enthalpy. It is represented by the symbol, Eg. Okay, it is represented by the symbol Eg. Electron gain enthalpy. So it is right like this, students. When you add, it's actually energy change. You write like this, energy. Before that, what about ionization energy, students? Whether it is endothermic or else exothermic?
Exothermic.
Very good.
Endotherm.
What is the definition of the ionization energy? I have to put some energy to remove Anika now. Correct? I have to put some energy. So that means energy is required. Correct? Energy is to be absorbed. Means Anika has to absorb energy and then I have to eliminate her. Means she should go out. Correct? So energy is applied on the system. That means this system will absorb energy. So that process is nothing but endothermic. Always remember, ionization energy is always positive. Always positive. It is an endothermic process. But what statement you gave here? That is nothing but electron gain enthalpy. It is nothing but energy change. Energy change when one electron is added to neutral gaseous atom. You can also add isolated. Energy change when one electron is added to one, not only one, yeah, usually you will add one electron. Energy change when electron is added to isolated neutral gaseous atom.
Ma'am, this means this electron gain energy enthalpy is opposite of ionization energy.
Opposite of ionization energy, correct? Okay, it is opposite to that of the ionization energy. But one exceptional case is there, because we in chemistry we have that, means for all the statements one contradiction will be there. Someone will be there to break that rule. Okay, so that is nothing but a noble gas here in case of electron gain enthalpy. So energy change when one electron is added to isolated neutral gaseous atom to make it anion, to make that element, that atom as an anion, to make that atom as a negatively charged species. You write atom as negatively charged species. This is a species. Okay, done. So now students, let me write the equation. So you take X atom, so which is an isolated neutral gaseous atom. Now students, what you have to do, add one electron. plus 1 electron. Let me write plus 1 electron. Students, see, that time ionization energy was there, right? So you have prepared some ion. What is that?
Cation.
Cation. So how cations are generated?
By removing
By the
electrons.
removal of, okay, by the removal of electron. Now what you are doing here?
Adding electron.
Adding electron.
Okay, you are adding electron. Adding electron in the sense, what is the charge of X neutral atom?
Negative.
Yes. That means negative means what is that actually?
Gaining electron.
Yeah, this is an anion. You are preparing anion now. Okay. So or else you can also write like this, students. Or X gas plus electron gives rise to X minus gaseous. So now students, you have to add some amount of energy, right? That energy is nothing but electron gain enthalpy. Sorry, it is Eg. Okay, electron gain enthalpy. You have to add certain amount of electron or else sometime the energy is released. I will explain. Okay, so this is nothing but electron gain enthalpy. Is it clear, students? Electron gain enthalpy definition is clear, right? So then I will check. I will, yeah, 1 minute. Students, you just concentrate on this periodic table. So which part of this periodic table gains electron?
P block.
P block. Why? Why not S block?
They are non-metals
They are non-metals means?
and they are electron deficient.
Yes, why it is electron deficient? Okay, leave that. It is electron deficient. Then why it has to absorb one electron or else why it has
To attain noble gas configuration.
to attain noble gas configuration? And noble gas configuration is highly stable. What about a S block elements now?
They
What
lose
about
electrons.
it donates electron and it becomes cation, right? See this metal, it donate one electron and it becomes cation. And here it gains one electron and it becomes anion, so that it will attain noble gas configuration. Here by the donation of one electron or one or two electron, it will attain noble gas configuration. Each and every element tries to attain noble gas configuration. Is it clear, students? Okay. So now tell me how electron gain enthalpy varies along the period. Okay, before that, let me write the general conclusion now. Yeah, variation of Eg. Students, 1 minute, I'll switch on this lights. Variation of Eg in periodic table. Okay, so now students, what happens along the period? Electron gaining and see Eg is related to electronegativity as well as size, and link those two and tell me the answer. Eg means what, students? You are adding one electron, right? Electron is added means it is nothing but electronegativity. Addition of electron in the sense it is a electronegativity, right? Electronegativity. So what happens if you add one electron? Sorry, what happens to the electronegativity along the period?
Increases.
Along the period it increases because size decreases, right? So what about the energy variation then?
Decrease.
Increases. Okay, so now here you write see only one thing, that means if you remember atomic radius variation, then remaining all are opposite to that of the all are in the sense ionization energy, electronegativity as well as electron gain enthalpy, all three are opposite to this. Okay, along the period size decreases, electron gain enthalpy, electron gain enthalpy What happens to the electron gain in terms of, before that, let me write electronegativity. What happens to the electronegativity?
Increases.
Only one student is responding. Remaining all are taking rest. Huh? Correct. Along the period size decreases. Okay, then what I have to write here?
Electronegativity
Yeah, electronegativity. What happens to the electronegativity?
increases.
Electronegativity. See, when you add one electron, then what happens? Large amount of energy is released. Okay, large amount of energy is released. So what happens? Electron gain. You just write 1 minute. Write like this. At that time, it becomes easy. Add electron. Size electronegativity increases when one electron is added. Large amount of energy is released. Large amount of energy is released. Okay, large amount of energy is released. Then what is the sign of that? What is the Eg value? Sorry, Eg value. It is more. Okay, it is more. But students, here we will use one more term, that is large negative. More is also written as a large negative. You write this. I will explain why it is so. Large negative. It becomes more or else increases, and you can also say it becomes large negative. Then you write down the group. Down the group. So what happens? Down the group, size increases. Okay, size increases. Size increases. So what happens to the electronegativity?
Decreases.
Electronegativity decreases. Okay, electronegativity decreases. So what happens when electron is added? Once again, large amount of energy is released, but energy with respect to this, because the size increases down the group, right? So now with respect to the period, so energy decreases. So you can write this as Eg decreases, because electron gaining capacity decreases. Okay, Viveka, electron gaining capacity decreases, so therefore Eg decreases. Is it clear, students? Or else you can say it is small negative. Large negative, small negative. See, this gaining capacity, this concept comes only in non-metal, right? Metal will not gain anything. It will donate electron, right? Is it clear? Metal always donate electron to attain noble gas configuration. Is it clear? So what about the energy, students? It is actually small negative. Your energy is also small negative, means it is almost decreased. Why? Students, I'm asking with you. Your energy is decreased. I'm not getting any answer here. Correct. So what happens in case of metal? Metals, they release energy. Okay, they will from this metal you can remove electron, but for this non-metal you can add electron to attain noble gas configuration. So therefore Eg is to be studied. I'll rub all those things. Shall I rub? Shushruth, you want to write something? Shushruth, you want to write? No, I'm not able to hear. Unmute yourself. Yeah.
Ma'am.
No, okay. Students, metals will not show this Eg. Only it is applicable for non-metals. Non-metals, Eg you can study because it gains electron to attain noble gas configuration. So now students, if you consider any non-metal and if you study Eg of that, then its Eg value is always negative. That means process is nothing but exothermic. Remember, But for noble gas, if you study, or else if you add one electron gain enthalpy means you have to forcefully you have to add one electron, right? Because it is completely filled, it has completely filled the electronic configuration. So at that time what happens, it has to absorb energy and it has to gain that energy. It has to absorb that energy and it is to be shifted from the ground level to excited state. So means from the one shell to another shell, you can say like that. The process is nothing but endothermic. Only noble gas elements shows a positive charge, okay? Then remaining all will show negative charge. So therefore students, we wrote it as large negative along the period and small negative down the group. Small negative means it is decreases. Students, write all these things. Decreases. Large negative means it is increases. That is the meaning. And in periodic table, name the element which shows largest value for Eg. So answer is nothing but chlorine, not a fluorine. Even though electron gaining capacity of a fluorine is very high, electron gaining capacity of fluorine is very high because its size is smaller than that of the chlorine, but electron gain enthalpy of chlorine is high than that of the fluorine. Students, you just write there, electron gain enthalpy of fluorine is less than that of the chlorine. Give reason. I will continue it in the next class. Electron gain enthalpy of fluorine is less than that of the chlorine. Students, so from next week onwards, so you have to attempt a quiz. Your next quiz starts from, I think, from Tuesday, 6:45 to 7:15. It's a chemistry quiz. The next quiz is always on Saturday. Tuesday as well as Saturday, you have to attempt a quiz in Ignis, that is chemistry quiz, half an hour. And it depends upon the questions, okay? Half an hour, maybe half an hour or else just 15 minutes. It depends upon the number of questions. Time will be mentioned there, but you have to start attempting from 6:45. Okay, is it clear, students? Yes, read well. And your next class is, today it is not there, okay? Because of some problem I could not upload, okay? So now read well. Your next class is on Tuesday, right? Okay. Yes, students, bye.